Imagine trying to explore the universe while peering through a fogged-up glass. You catch glimpses, faint shapes, fleeting glimmers, but the truth remains hidden. For decades, even the legendary Hubble telescope left vast portions of the cosmos shrouded in secrecy. But in 2021, everything changed. A new eye in the sky began peeling back the universe's veil, and it's revealing wonders we never thought we'd see. For most of our history, humanity's view of space has been limited to the narrow band of visible light. That meant enormous stretches of the cosmos remained invisible, concealed in wavelengths our eyes, and many telescopes, simply couldn't detect. The James Webb Space Telescope shattered that limitation. Stationed a million miles from Earth at a gravitational sweet spot known as a Lagrange point, Webb operates in the deep cold of space, undisturbed by Earth's glow. Its power? Infrared vision so sensitive, it can see the heat of a bumblebee from the moon. This lets it look back across time, glimpsing the earliest galaxies after the Big Bang, and piercing through thick clouds of cosmic dust to watch new stars and planets being born. It's like putting on a pair of night vision goggles at a smoky concert. You suddenly see everything that was always there, just hidden. Back in 2017, astronomers in Hawaii spotted a faint, fast-moving speck streaking across the night sky. At first, it looked like an ordinary comet or asteroid, until its trajectory revealed a startling truth. This object wasn't bound to our sun, it was a visitor from another star system. They named it Oumuamua, Hawaiian for scout, or messenger from afar. But Oumuamua was no ordinary traveler. It had no glowing tail, no surrounding cloud of gas, yet it accelerated as it left the sun, as if pushed by an invisible hand. Its brightness flickered wildly, hinting at an odd, elongated shape, something between a cosmic cigar and a pancake. Imagine a skyscraper-sized shard tumbling through the void, breaking every rule in the astronomical handbook. Scientists were baffled. Was it a fragment of a shattered planet? A bizarre new class of comet? Or could it be artificial? The debate was fierce, but before answers could be found, Oumuamua slipped into the darkness beyond Neptune, too faint for most telescopes to follow. Years later, Webb changed the game. Using its unmatched sensitivity, astronomers plotted Oumuamua's likely path, taking into account every strange swerve in its motion. They aimed Webb's gaze at a tiny patch of sky, searching for a cosmic needle in an endless haystack. For hundreds of hours, Webb collected every whisper of light it could detect. Finally, they found it, a faint, drifting speck exactly where predictions placed. Against all odds, we had rediscovered the ghostly traveler. The first image wasn't dramatic, just a blurry gray smear, but it was enough to set the scientific world on fire. Webb revealed Oumuamua as a jagged shard roughly 3 times longer than it was wide, natural in shape, not engineered. Even more intriguing, its instruments detected a faint halo of water vapor, completely invisible to older telescopes. That delicate outgassing explained its odd acceleration. As sunlight warmed hidden ice beneath its surface, tiny jets of vapor nudged it forward. No alien engines, just the subtle physics of a natural wanderer. This discovery didn't just answer a question, it rewrote an entire chapter of modern astronomy. For years, Oumuamua had been the subject of endless debates, late-night arguments, and headlines filled with wild speculation. Was it a comet? An asteroid? A fragment of an alien spacecraft? Or something so strange we didn't even have a category for it? Scientists had theories, models, and simulations, but no concrete evidence. Every explanation seemed to raise more questions than it answered. And because the object had sped out of view so quickly in 2017, all anyone had to work with were a handful of light measurements, a puzzling trajectory, and a lot of imagination. Then came the James Webb Space Telescope, and with it, the breakthrough moment astronomers had been hoping for. Its ultra-sensitive infrared instruments didn't just detect Oumuamua again. They began peeling away its mysteries layer by layer. For the first time, we had hard, measurable data that could explain its odd behavior and peculiar appearance. And with those readings, the picture of what Oumuamua really was came sharply into focus. It turned out that this wasn't just some random rock drifting between the stars. Webb's observations revealed something entirely new, a type of interstellar visitor we had never seen before. This was a body with a hardened, rocky exterior, darkened and baked by countless years of exposure to the radiation and particle bombardment of deep space. But hiding beneath that shell was an icy heart. It was a frozen core of water and possibly other volatile materials, sealed away like a time capsule from another star. This discovery challenged the very definitions we'd been using for decades. Traditionally, comets are icy bodies that, when warmed by the sun, release streams of gas and dust, creating a visible tail. Asteroids, on the other hand, are solid, rocky, and largely inactive. But Oumuamua didn't behave like either, at least, not on the surface. It had no bright tail, no glowing coma, nothing that would give it away as a comet. Yet Webb detected a faint, ghostly mist of water vapor around it. The activity was subtle, too subtle for older telescopes to have noticed, but it was enough to explain the strange, unaccounted for acceleration in its path. The reason for this hidden behavior lay in its surface. Years, perhaps millions of years, of traveling through interstellar space had baked its exterior into a crust so tough and dark it acted like armor, preventing most of the interior ice from escaping. Only small pockets of gas could leak out through microscopic fractures. These tiny jets, though invisible to traditional optical instruments, created just enough thrust to nudge the object's trajectory in ways that defied initial predictions. In a single stroke, Webb's discovery erased years of guesswork. Theories of alien engines or solar sails faded into the background. Instead, scientists were left with something perhaps even more extraordinary: proof of a brand new class of comet that had originated in another star system entirely. This wasn't a body that had been born alongside our sun and planets. It was a migrant from a distant world, forged in the gravity and chemistry of an alien solar system, and then flung into the void on a journey that eventually brought it here. The implications were staggering. For one thing, it showed us that planetary systems all across the galaxy might be ejecting such fragments into interstellar space on a regular basis. Some of them, like Oumuamua, may wander for millions or even billions of years before encountering another star. This meant that our own solar system is not an isolated bubble, but part of a vast cosmic interchange, a kind of slow-motion traffic of rocky and icy messengers drifting between the stars. And then came the most astonishing revelation of all: water. Water, the universal solvent. Water, the key ingredient for every form of life we know. The fact that Oumuamua carried it within its icy core instantly elevated its importance. If one interstellar visitor brought water, it's reasonable to think that countless others might be doing the same. The cosmos has been whispering to us for billions of years. Last, we can hear it.